that is called as a new state. Second one is called as a runnable state. Runnable state. So once it is entered into the runnable state, then after that it is going to the running state. Okay. Normally, once it is a running state, whether the running state is completed, it is come to outside. So that means once the task is completed, it is entered into the outside. So that is when the task is completed, then it is exit from that state. That is called as a dead state. That is called as a dead state. Okay, but sometimes some programs require maximum time. So now that task or that thread enter into the wait state or sleeping state. So once the program, the scheduler can allocate another thread to be processed. Another thread to be processed. So that's why there are 5 stages are there. First is called as a new thread state. That is to start a thread. First you can create a thread state. Second one, it is the runnable state. So first creation of the thread. Second is the runnable state. Then it is entered into the running state. After that, there are 2 chances are there. Whether that the thread can take longer time, that is called as the sleeping time or a waiting time, then it is entered into the waiting state. So after such a waiting time, then it will complete the task and exit from the state. That is called as a dead state. Okay. Second possibility, after running is complete immediately, then it is entered exit from the state. That is called as a dead state. So these are all the 5 states called as a life cycle of the thread. These are all called a life cycle of the thread. Right. So this is called as a new thread. How to create the new thread? I already mentioned java.lang.thread. It is already existed. So JVM can take care about that. Next. So this is called a thread state. This is a new thread. How to create it? First, if you want to running, then you can create the new thread. Normally, there is a default or a one minimum. At least if you are using the multi-threading program, at least 1 thread is created JVM. That is called as a main thread. Don't confuse about the main method. Main method is starting the program, but main thread is initializing the thread programming. So that's why if you are using the thread program, minimum 1 thread is compulsory. That thread is called as a main thread. That is called as a main thread. So later you can understand clearly in the program time. Okay, right. So first you want to create a thread. So for the thread, you should create. The thread is in the state when the instantaneous of a thread object create a new thread, but not start. So first thread is created. But it is not once a start is initiated, then the thread enter into the runnable state, a runnable state. Okay, so that's why the first state is creation of the thread by using the thread object. So simple step is to create a thread you can use by the thread object. That is the first point. Second point, once a new state is created, then you are entering into the runnable state after start method. After start method. So that's why this is called the start method. Okay, right. Next. Okay. So anyone, only one start method. Well, okay. Next. Okay. So this is the next point. Second state is runnable. Okay. Before that, I want to explain. Thread starts life in the ready to run state. You can call only the start method. That's what I'm saying already. So calling any method besides start causes any illegal. Yeah. So that's what I'm saying. Third point is that suppose once a thread is already calling state, while it is calling state, if you are calling another thread, it can give some error. Right. So first point is that by using the thread object, you are creating the thread. Second point, once you are entering into the start, then that thread is in the runnable state. Third one, while one thread is runnable, if you are calling another thread, then it will give some problem. Okay, right, next. This is the runnable step. What I'm saying, the runnable step, one turn start program initiated, then it will be executed. So this is entered into the runnable. The your program running is start, okay, but not completing. Okay, right. All right. So once it is, there are two stages. Once it is starting, then after running is starting, then what happens? There are two stages. First, it can complete it can finish its task, or it can be entered into the wait state. Enter into the wait state according to the program or task requirement. Okay, next. This is a not runnable. Okay, what I'm saying that once after runnable, once you are starting that, then it is entered into the running state. In the running state, there are two stages. One is the runnable state, second one is the non-runnable state. What is the non-runnable state? Because it is entered into the sleep mode. So that's why there are different points out there. A thread becomes not runnable when one of the following four events occur. What are the things? Number one, sleep method. Sleep method. Sleep method stands for that program will require a certain time. So that means 100 milliseconds or 100 microseconds, 1000 microseconds, that will sleep for a particular time. So that is called a sleep method. Second one is suspend, because it is a kind, once it is entering into the infinite sleep time, then it will be suspended. Next, that's one wait time. So it can be wait. Why? Because in the multi-threading point of view, one output of the thread is required to the input of the another thread. In that aspect, it can be that thread should be waiting for the result of the previous thread. So at that moment, the thread can be, I repeat, once a thread is initiated, so this output can be accessed by the another thread, input of the another thread. At that moment, that thread can be waiting. The thread can be waiting. So the best example, you want to calculate the factorial. You want to calculate the factorial. That is a recursion problem. In the recursion problem, for each and every time, tons. So in the factorial program, what happened? It is a multiplication takes place. So this multiplication can be entered into the next program. So that's why that is the input of the next one. So once a calculation is over, then it is the output is entered into the next one. So that's why at that moment it is waiting stage. Okay, right. So sometimes, okay, this is called the thread is blocking on IO and waits for its completion. Sometimes according to the priority. So I can explain very short time priority. I can explain the priority. Once a highest priority comes while the lowest way running, then it can be blocking. Sometimes it can be blocking. So the four methods are important. Number one, sleeping method. Number two, suspend method. Number three, wait method. Number four, blocking. So this is these four all comes into the not runnable state. Next, dead state. What is the meaning of the dead state? That dead state stands for after running the present thread and finishing it thread and enter into the exit state. That exit state is called as a dead state. That exit state is called as a dead state. So that's why I'm saying that run method has finished executing when the stop method invoked. Okay, so that means once a thread is running successfully, its task or then it is entered into the exit state. That is called as a dead state. Right. So that's why I'm saying that I repeat that is a set of instruction to perform a certain task. Multi-threading stands for multiple programs can perform multiple tasks in a single program. Second point, they can use the same memory space. They can keep the CPU busy, always busy. Next one. So next step, how to create a thread? The thread having a 5 state, that is called as a life cycle. What is the life cycle? First is called as a creation. So that created by using the thread object. Second one, once a creation, it is not running. So how it is entered into runnable state? after start is initiated, it is entered into the runnable state. Runnable state. So once it is runnable state, there are two chances are there. So it is a running state or not runnable state, because in the non-runnable state transfer, it can occupy the four stages. So what are the four stages? Sleep mode, sus mode, wait mode, and blocking mode. Because there are certain conditions are there. So that's initially I'm saying that thread to thread communication should be takes place. Thread to thread communication should be takes place. Okay, in a easiest way. All right. So next, once it is complete, then after running state, runnable start, then it is in the running state. In the running state, there are different chances are there. So wait is evolving. Once it is closing, then it is entered into exit from the thread, and then that is called as the dead state. Right. Next. So priority. So priority gives preference. If because in the multi-threading, multiple programs are there. Each and every time, a specific thread is accepted, and that can be accepted by the CPU. So how to select a particular thread? That is a very important. How to select a particular thread? The selection of the thread, because I repeat, single program, multiple task. So multiple task at the time, the CPU is busy with one program. Okay, so that's why how to select a multiple task. So which task I want to select it first. So selection, that is called a priority. So who can select the, that is called a priority. If there's so many number of items are there, which item can be preferred first is called as a priority. The best example, our college, our principal sir, HOD sir, and myself. So three people are there. So who can give the highest priority? So obviously principals are the highest priority. So once the principals are task is complete, then go for the HOD sir. So while the HODs are completed, then least priority is the step. So this is called as a priority. Okay. Similarly, in the multi-threading, which task completed first, that can be selected by the scheduler. That can be scheduler. Okay, scheduler. Scheduler stands, there are two types of schedulers are there. There are two types of schedulers are there. So two methods. So there are two working principles. One is called as a time slicing. One is called as a time slicing scheduler. Second one is called a preemptive. Okay, preemptive. So preemptive is completely depends upon the priority, and the time slicing completely depends upon the slicing the time. Okay, all right. So before the thread priority. So suppose if you want, what is the generally execution of the thread? First, always highest priority is executed. So that means once it is a selection of the highest priority, then there is an option that is called a set priority. Set priority. Okay, set priority. To find out what it is priority, you can use the get priority method. I repeat, suppose if you want to set, then you can use the set priority, and you want to know the what is the present priority, then you can use the get priority. So by using these two, I can find out what is the priority. Suppose if you want to execute this immediately, then you can set the priority, highest priority. What happens once a highest priority is executing, then lowest priority should be waiting after successfully entering into that state of the highest priority, then second highest priority device can be activated. Not device, that is a thread can be activated. Okay. So what are the priority levels are there? Minimum priority is the 0 level. What is the maximum highest priority is the 10. Suppose default priority is the 5. So you can change by using the set priority. You can change the set priority. Okay. Next one. This is called as a thread priority. So priority get greater access to available resources than the lower priority. That's why I'm saying it to you. Okay. Good. Next. who can select the priority? The thread scheduler. I repeat, scheduler. So there are two types of schedulers. Are the scheduler, that means schedule. So at what time, what thread can be selected, and how to execute that. So selection of the thread is called as a scheduler. So after scheduling a thread, that thread can be executed by the CPU, single CPU, single CPU. Once a specific thread is selected by the scheduler, that thread can be executed by the CPU. That thread can be processed by the CPU. Okay. So what are the different methods in the scheduler? Two methods. Number one, preemptive scheduling. Preemptive scheduling stands for you are assigning the priority to the particular thread. So either by JVM or by user can set. Okay, right. So that's why you can set the priority. So according to the priority, which thread having the highest priority, that can be processed by the CPU. This is the first one. Okay, that can be entered into the runnable. Once it is entered in the runnable state, there are two chances, whether it is running or it is entered into waiting. Once it is entered into the waiting state, then in that time, CPU cannot be keeping idle, keeping free. So then the scheduler can allocate another next highest priority thread allocation. Then that thread can be executed. So what is the main aim or object of the multi-threading? To keep always the CPU busy. That's the aim. So I'm not supposed to keep the CPU in free time. So that's why once the highest priority is entered and it is entered to wait state, then at that moment, the second priority comes in. So while within the second lowest priority is executing time, the highest priority completing, then it should be entered into the wait state or blocking state or sleeping mode. So now, once it is waiting into state, so then it is entered into running state and it is exit from the dead state. So in the preemptive scheduling, what happened? You should give always highest priority thread. Prefer to highest priority thread. Okay. Once it is entered into the wait state, at that moment, the next highest priority should be allocated. Right. Next, another method is the time slicing or round robin scheduling. So in the round robin scheduling, every thread is a equal priority. Every thread is a equal priority. So how? So that means number one, the time can be divided into according to the threads. According to the threads. Okay, according to the threads. So suppose 5 systems are there. So then the time can be divided into 5 slots, 5 time slots. So first slot is allocated to first device, second slot is allocated to second device, and third device, fourth device, and fifth device. Once a time slot is available, within that time slot, that thread can be finishing its task, finishing the task. Suppose if it is not finishing, then it can be wait state. It can be entered into the wait state until the time slot is allocated. Until the time slot is allocated. So first slot is over. So then next slot. So in the next slot, second device, that second thread comes into the picture and its thread can be completed. Okay, but there is some drawback is there. Suppose a time slot is allocated, within the time slot, the thread is completing its task very fast. So there is time left is there. But what happened? There is some time is remaining. That can be wasting out. That can be wasting out because the slot is allocated. Whether you are doing or not doing, you are performing or not performing the task. You can allocate a task certain time. Within this time, you can perform. Whether you are utilizing or not utilizing, that's enough. You are very fast, you are completing the task, then some time is remaining. So that can be wasting out. So slightly. So next, third one. Then this process continue until the fifth one. Once fifth one is over, so then again the next start, that is called as a round robin method. That is called as a round robin method. So in this process, every time, so every device, every thread is a equal priority. So what is the main thing? If the having a highest priority, that can be accessed by the CPU. This is normal point of. So that's why if you are keeping, if you are arranging all the threads are equal priority, then what happens? Time slot is allocated. That is the highest priority. So that can be accessed. So time is over. So next device comes into the picture. So that's why that thread is highest priority. So that can be executed. So this is called as a time slicing or round robin scheduling. So each and every time, each and every thread is a equal priority, or that is a highest priority. So that highest priority can perform its thread tasking within the specific time, within the time allocation. Okay, right. How to suppose there is a chance you can assigning a equal priority. You are assigning a equal priority to the another thread also by using the yield method. By using the yield method. So that means yield method. A call to static method yield defined as the thread calls will cause the current thread in running state to move to the runnable state, thus relinquish the CP. The yield method gives the other thread of the same priority. To allocate the same priority to the other thread, you can use the yield method. You can use the yield method. Okay. So now it is already explained in the previous one. Okay. Sorry guys, I think the next class is ready. I can continue the next class. Okay. The time is 9:50. Thank you.